So essentially, your agentic framework for composable digital solutions offers a structured approach for integrating multi-agent systems into manufacturing operations. So can you help us understand why having such a structured framework is important to begin with?
And I wrote another article, which I call the genius of the Toyota system, right? That the Toyota system, actually, if you look at it, they realized the nature, the nature of a manufacturing system being very complex. In fact, manufacturing systems as systems, without not necessarily, not only the software, they are classified as systems that are called complex adaptive systems. So they actually fit into a class or category of systems that are inherently in chaos. In these systems, there are patterns that indicate whether things are going one way or the other, and we're trying to replicate those patterns. And what Toyota understood is that there are ways to impact those patterns. So, one of the things that causes in complex adaptive systems, if you push the system, if you take out the slack, and think about traffic, you put more cars on the road, highly likely that's going to be a traffic jam, right?
Yeah.
And it's the same thing in the Toyota. Basically, the whole idea of pulling versus pushing is a mechanism to keep it from getting into the bad. Because when you pull, think if you also did that on traffic. The problem with traffic is it's pushed because the car behind you is trying to get closer and closer, and the guy in front is not moving fast enough, or some obstacle. So if you pull, you get more flow, and you get less disruption, and therefore you get less bad things in the system. The other thing is remove the obstacles. Remember, even in traffic, if somebody crosses the road or something falls on the road, like, you go sometimes something fell off the car and there's something on the road, boom, there's a traffic jam. What do you do in Lean is you look for those obstacles and remove those obstacles as fast as possible. The and-on is meant for that, right? Yeah. So that is a behavior. If you remove that behavior, the system is not going to get into situations where it's bad. So again, they understood the mechanisms of a complex adaptive systems, and they put in methods and tools, Lean methods and tools, to make sure that the system keeps in the orderly side, or behaves the way they want. So that's a complex adaptive system. And what makes a complex adaptive, and I'm getting to agents in just a bit, but a complex adaptive system is that it's made of discrete entities, right? It's a discrete system, an entity that follow a path, right? So they have a discrete entity that follow the path. And that's what happens in manufacturing. Discrete entities are the units, the machines, the people in there, and they're moving stuff around. Now, if you take the agent part of it, actually, agentic systems also behave the same way. They are discrete agents, each doing their job, and they operate together. Now, they themselves are forming a complex adaptive system. And here comes the magic. If you take a complex adaptive system to manage a complex adaptive systems, you get the best behavior. Now, if you get a agentic system, which is complex adaptive, to control the complex adaptive, and you can control the agents, then you have the best of both worlds. You have the adaptability that you need, but still you have a way to manage it in a way that it stays in a place where it's actually very effective. And here comes the framework. How do you do that? You need to apply a framework. You can't just have agents do stuff, right? You need to define the goals, and you need to define what governs, and you need to put in mechanisms to keep them away, to make them to stay away from the bad behavior.